The US built the most aggressive tech restrictions in decades to slow China down. And for a while, it looked like it was working. But they may have told China exactly what to build instead. Last December, Reuters revealed that former ASML engineers had been secretly working in a Shenzhen lab under fake identities. By early 2025, they had a working prototype of the exact machine China was never supposed to have. The ban didn't just block China. It acted like a blueprint. But here's the surface story, and I want to be fair to it. It's not wrong, it's just not the whole picture. Starting in late 2022, the US government agency called the Bureau of Industry and Security, or BIS, started cutting China off from the chips that power AI. Think of them as the referee of what American technology can leave the country. Hard numerical limits. Basically, if your chip is fast enough to train a serious AI model and you want to sell it to China, you need government permission, and you probably won't get it. And for that, Nvidia had to design a special, slower version just for the Chinese market. And the BIS eventually banned that too. By late 2024, they added controls on memory that sits next to the processor, because it turns out memory is just as much of a bottleneck as the chip itself. And by early 2025, they were requiring the factories that physically assemble the chips to verify transistor counts on everything they touch. And I get why that looks like progress. Every time China finds a workaround, the US closes it. Shouldn't that mean it's working? Here's what I think actually is going on. One analogy, stick with me. Whack-a-mole. Moles pop up. You hammer them down. Now imagine the moles have engineers. Every time you hammer one down, that mole goes on the ground, looks exactly which hole just got hit, and comes back up one over. That's what's been happening. Every hole the US closes, chips, memory, then packaging, sends a precise signal to China. Now, 3 times this has played out, each one harder to dismiss than the last. The first mole, chips. No advanced chips to China. Nvidia designs a slower version, tuned just under the cutoff. BIS bans that too. Mole goes down, China comes back up in the manufacturing hole. SMIC, China's biggest chip factory, starts making chips that ends up in Huawei's Mate 60 phone. When analysts tore that phone apart, the chip was performing at roughly a 7 nanometer level, which raises the obvious question: how do you make a cutting-edge chip without the machines that making cutting-edge chips build software? Specifically, a technique called the inverse lithography, or ILT, which basically means AI calculated the most precise pattern of light to shine through an older machine, squeezing every bit of performance out of it. Older machines doing the work of newer ones because the software closes the gap. A peer-reviewed paper published in July 2025 documented that Chinese university, Tsinghua among them, are advancing this software themselves, not copying Western research anymore, publishing original work. The second mole, memory. Late 2024, BIS realizes the memory bandwidth next to the processor is just as much of a bottleneck as the processor. Adds it to the ban, moles goes down. Huawei's response: take 2 of the older chips and package them together so they behave like a larger one. That's the Ascent 910C. Not a new chip, a packaging trick. So the US passes a rule requiring factories that do packaging to count transistors on everything they touch. More than 30 billion transistors on a chip, and the factory must prove it isn't controlled before they can touch it. On the whack-a-mole machine, you now handed the hammer to the machine itself and told it to hit anything big. The mole now has to stay small enough not to trigger the sensor. The third mole, EUV lithography, is the machine that makes the most advanced chips in the world, and only one company builds it: ASML in the Netherlands. The US pressured its allies years ago to stop selling these machines to China. The assumption was simple: without EUV, China stays a decade behind. But think about what that ban actually communicates. It says this machine is the irreplaceable checkpoint, and the fastest way to get it is to find the people who actually build it. Reuters published an investigation last December. A team of former ASML engineers were recruited into a classified lab in Shenzhen. They worked under the fake identity. In early 2025, they got a working EUV prototype running, not producing chips yet, but the machine generating the right light. The Chinese government wants chips by 2028, and people close to the project say 2030 is more realistic. Either date is years ahead of what most experts thought possible. The mole came back up in the build the whole machine yourself hole. Recruiting those engineers wasn't subtle. Starting packages were around $500,000 plus housing. Some people even were offered Chinese passports. ASML even won a court judgment worth over $800 million against a former engineer for stealing trade secrets. He declared bankruptcy and kept working in Beijing with government backing. Okay, that's the real picture. Now let's talk about what it actually means. The export controls aren't failing. They are succeeding at the wrong thing. Every rule BIS writes has to be built around a number. A transistor count, a memory density, a processing rate. Think about what that produces from China's side. Every new rule is also a ranked list of exactly which capabilities are strategically important to build at home. The memory band says this density level matters. The transistor rule says this chip size matters. The earlier chip rules say this level of AI processing power matters. Chinese response to each new rule has been faster than the one before. That's not coincidence. The rules are functioning like an engineering curriculum, and China is spending accordingly. In 2025, China put $38 billion into chip-making equipment. More than South Korea, more than Taiwan, more than anyone else. So here's the question that actually matters. What does the world look like when they don't? There's an optimistic version. The controls buy 5 to 7 years. American AI labs compound quickly in that window, that the gap becomes impossible to close. Well, that's the theory. But here's another version. In that version, the controls don't slow China down. They give China something never would have built through competition. A fully independent semiconductor ecosystem. Raw materials. China already controls roughly 99% of global gallium production. Factories, assembly lines, software, and now potentially lithography machines themselves. Not a copy of what the West built. Something designed specifically to be immune to pressure being applied today. That's not speculation. A working EUV prototype, original lithography, research from Tsinghua. Government funds injected roughly $50 billion in a single year. Engineers sleeping on site 6 nights a week, phones taken away at the door. Those aren't signs of a country slowing down. The controls were meant to preserve a technology gap, but they may have triggered a technology race that no rule, no threshold, and no hammer can stop. Here's the comparison I can get out of my head. ASML took almost 20 years to go from the first EUV prototype to the first commercial chip, and that was with unrestricted access to global supply chains, the best engineers in the world, and no political deadline. And China is trying to do that in 5 years, with stolen blueprints, recruited engineers under fake identities, and a government calling this its Manhattan Project. Maybe physics won't allow that compression. Maybe 2 decades of accumulated knowledge can't be shortcut, no matter how much money you throw at it. Or maybe the most powerful force in the history of technology isn't any particular machine. It's a country that knows exactly what it needs and has decided that not getting there isn't an option. We don't know which story we are in yet, but I would be a lot more nervous if I were in Washington than if I were in Beijing.